Okay, so for today's warm-up, we're going to be doing the area of the rhombus there to the right. So we need to remember our formula for the area for a rhombus, which is 1/2 times diagonal 1 times diagonal 2. Now if you notice, they're just giving us this length here. I'm going to put it in red, which is 4 meters. Hopefully you remember properties of a rhombus. This side is going to be the same as the one over here, so this is also 4. So that makes one of the diagonals, let's say that's diagonal 1, as 8. We still need to find diagonal 2. So diagonal 2 is the one going up this side, which is going to be the same going down this side. So if you notice here that a rhombus, you make a right angle here. We have a 30, 60, 90 now, right triangle. This side, that's 4, is opposite of the 30-degree angle. So I'm going to take this out so you can see a little bit better here. 4, 60, 30. So to get the side opposite of 60, we know it's going to be 4 root 3. So this piece is 4 root 3 plus another 4 root 3. So what is 4 root 3 plus 4 root 3? It's kind of like 4x plus 4x. It's 8 root 3. So diagonal 2 is 8 root 3. Now let's go ahead to the problem, the formula, 1/2 times 8 times 8 root 3. And it says to leave this in radical form. So we have 8 times 8 is 64. Half of 64 is 32 root 3. The units are meters squared. All right, so today's objective is 10.3, is to be able to find the area of polygons, regular polygons. And what were regular polygons? They all had sides the same and angles the same. Some important vocabulary to write down and to label here for 10.3. So we have a couple different things in a regular polygon. We have something called, which is a weird name, called apothem. A-P-O-T-H-E-M, apothem. The apothem is the line that's perpendicular from the center to one of its sides. So in this picture, the apothem is this red dotted line. This is the apothem. So it's coming from the center, perpendicular to a side. This little dot here, right, this little dot is the center. This blue line is a side. And now this side here, they don't have anything labeled here, is actually a radius. So if I was to put a circle around this 6-sided hexagon, that would be the radius of the circle. So make sure you have those in your notes. All right, to find some angles now in this polygon inside. So here we have just a portion of an octagon that has 8 sides, right? So how am I going to figure out the measurement of these angles inside that are going around, 1, 2, 3, all around here, which are labeled as angle 1 here. So to get angle 1 measurement, I'm going to take my full circle, 360 degrees, divided by the 8 sides. And that turns out to be 45 degrees. So angle 1 here is 45 degrees. Angle 2 now, if you notice, is part of angle 1, but it's split completely in half. So what's half of 45 degrees? 22.5 degrees. And now to get angle 3, which is down here, so let's see if I could resketch this so we could see a little bit better. There's the right angle. This was angle 2, which was the 22.5 degrees. We may have the right angle, so I need this angle 3 down here. So we're going to add it up and subtract it from 180. So angle 3 comes out to be 67.5 degrees. All right, let's practice this one more time again. Here we have a pentagon. Pause the video, see if you can figure out the measure of angle 1, angle 2, and angle 3. Okay, angle 1 here I did the 360 divided by the amount of sides, which is 5, so 72 degrees is angle 1. To get angle 2, I split that in half again to see that piece of that right triangle there. 72 divided in half is 36. Now to get angle 3 up here, again, we have that right triangle. We have already the 36, so we add, subtract from 180. That's how we get angle 3 to be 54 degrees. Here is the formula for the area of the polygon. So what we're doing is we're taking the apothem, multiplying it by the perimeter, and then timesing it or dividing it by a half. Okay, so this is an important one. 1/2 A times P, 1/2 times the apothem times the perimeter. Okay, so let's take a look at this example here. What is the area of this pentagon with an 8 centimeter apothem? So this is 8 centimeters, this red dotted line. The sides going around are 11.6 centimeters. Now we're going to use the formula for that area is 1/2 times the apothem times the perimeter. So the apothem is 8. What will be the perimeter here? Well, perimeter is multiplying the amount of sides times every side. So we have 5 sides and they're each 11.6. Okay, and we do our math. We get 232 centimeters squared for the area. Okay, here we have a honeycomb, which are hexagonal cells. The length of one side is 3. What is the area of the cell? So we need to find this apothem here. We don't have it, this apothem. All right, how am I going to get this apothem? Well, if you notice, they're already giving us the angles inside a hexagon. So this right triangle here that I'm going to pull out, we got 1.5. We're looking for the apothem. We know this is 30, so this has to be 60. So this is a 30, 60, 90 right triangle. What would be side A then? Looking at our special right triangle formulas, A would be the 1.5 times root 3. What would be the perimeter? Well, the perimeter is the sides times 6, right? So we have 6 times 3, the perimeter is 18. So now I'm going to plug it in my formula. Okay, so it's 1/2 times the area, times the apothem, 1.5 root 3, timesing it by 18, the perimeter. Okay, and I get it to be 23.4 millimeters squared. Okay, find the area of this polygon, but now they don't want the answer in decimals, they want it in radical form. So again, let's see how many sides we have here. 6 sides. So we do have the apothem. We need to find the side length. This side length here. All right, so to get it, we need the angle that's being made here. And remember, we're doing 360 divided by 6, which is 60, and divide that in half to get 30. So here's my 30-degree angle here. We have a special right triangle again. Okay, so we need to get the side now opposite of the 30-degree angle here. We have the one opposite of 60, which is 4 root 3. So the one opposite of 30 is 4. So if I transfer it over into the picture, the 4 is just here to here, 4. I need the whole side length, so this is another 4. So the side length is going to be 8. So the formula says 1/2 the apothem times the perimeter. So 1/2 times 4 root 3 times the perimeter is 8 times 6, because you got 6 sides there. So if we put these all over 1, let's go ahead and multiply the numbers. So on the top, I multiply across 4 times 8 times 6, then I'm going to divide it by 2. So I get it to be 96 root 3, that's in simplest radical form, square units. So this is the area. All right, this last question is find the area of each of these in radical form. You could pause the video, come back to see if you're getting it correct. Okay, my bad. This first one we did on the previous slide there, the 96 root 3 one. All right, the middle one here, you're given the radius for 7. So you're doing the 360 divided by 6, divide that in half. So I'm getting 30 degrees there. We know that this lovely side here, the hypotenuse is 7. Oh, I just erased everything. Okay, to get the apothem side, going opposite of the 60 and the 30-degree angle here. So the 30 is going to be half of 7, so that's 3.5. The one opposite of 60 is 3.5 root 3. So my apothem is 3.5 root 3. My whole side length are these two added together, which is 7. So now over here I'm plugging in all that stuff 1/2 times the apothem times the perimeter, 6 times 7. Multiply, divide, and here is the area, 73.5 root 3. 73.5 root 3. And then the last one is dealing with a triangle. 360 divided by 3, which is 120. Divide that in half, so now the angle up in here is 60. I tried to make it down here, this triangle, so that you could see it. Flip the other way, the correct way. So let's get our hypotenuse. They give us 2. To get the side opposite 30 is 1/2 of that, so it's 1. And then the one opposite of 60 is 1 root 3. But the whole side length is root 3 plus root 3, which is 2 root 3. So I have my apothem is 1. My perimeter is 2 root 3 times 3 sides. Multiply across and divide. The area for this triangle is 3 root 3.